Hi, I'm Mike Rowan. Welcome to part 2 of Retro Printing for Fun and Profit, sharing new and old printers with new and old computers. In part 1, we learned how the color computer communicates with a printer over a serial cable. In part 2, we're going to take the time to get Raspberry Pi OS installed and running on the Raspberry Pi Zero. If you're already familiar with this process, feel free to skip to part 3.
Okay, I'm just going to go over a little bit about the Raspberry Pi that we'll be working with. We'll actually be working with two different ones, but this is a Raspberry Pi Zero wireless. It's very small, as you can see, but very powerful. It has built-in Wi-Fi, USB, HDMI, and it's ideal for our application because it's so small it won't take up any space. You could Velcro this to the side of a printer if you wanted to. Now the Raspberry Pi itself, you can find it for from $7 to $10 for the Pi Zero. But of course, you need some other things to make it work. Now, I bought this startup kit from Vilros for about $28, which gives you just about everything you need. You're going to need a power supply. It comes with a USB, the miniature to regular size USB dongle. There is an HDMI, the micro HDMI or mini HDMI to normal HDMI if you want to hook it up to a monitor. It comes with a case. You're going to want that. Also has a heatsink and a reference card. The other thing you're going to need to purchase in addition to it is a memory card for the operating system and a mini SD, micro SD. I recommend that you get a 64 gig micro card so you have enough space for everything you want. I'm also, at some point, we'll work with the Raspberry Pi. This is a 3B Plus that I have. So any of these should work for what we're doing with the Raspbian operating system. Later, I'll be pulling out this Raspberry Pi because it has the header pins, the GPIO pins soldered in, and I don't really think I'm going to need to do that for the Raspberry Pi Zero, which of course you're welcome to do. I'm probably going to use USB instead of the GPIO headers, but we will be using the GPIO headers on the Raspberry Pi 3 just so we can cover that.
All right, we're going to walk through getting the operating system installed on an SD card, micro SD. First, you'll want to go to raspberrypi.org, and we want to go to the software link, and you're going to want to install the Raspberry Pi OS Raspberry Pi Imager. This is a great tool. If you're working with Raspberry Pis at all, you'll want to grab this tool. So you can download it for Windows and Mac OS. I'm running Linux Mint, so it's coming up with the download for Ubuntu for x86 on my laptop here. So that's fine. That'll work for Linux Mint. Should work for most Debian-based Linuxes. So save that to. I'll save it to my desktop. And then I'm going to open it and I'm going to install it. The nice thing about the Raspberry Pi Imager is that it's kind of the etcher utility, but it's been customized so that you can just select which image you want from a drop down and it will automatically grab it across the internet to get it installed. So it makes it very nice. Oh, there it is. Imager, Raspberry Pi Imager. So I'm going to open that. Let me just close my browser here. So it's as simple as this. You're going to choose your OS. You can choose the Raspberry Pi OS. That's the full one with the desktop. You can click here on Other, which is what I'm going to do. And I'm going to select the Raspberry Pi OS Lite. And this has no desktop environment. So I certainly don't need this for a print server. I'm just going to select that. I don't need the GUI and all that. Then I'm going to select, choose an SD card. You'll need to plug an SD card in. If your computer doesn't have an SD card slot on it, which some laptops do, some don't. For about $10 you can pick up a USB card reader. That's what I'm using on this. Those are widely available. Okay, we're going to choose our SD card. We've got a generic 64 gigabyte card, and then we click Write. It'll tell you you're going to overwrite the data on here. You want to continue? Yes, I do. Asking me for my password. So we'll let that run and come back when it's finished. Okay, it says it has been written. You can now remove the SD card from the reader. We will remove the SD card from the reader, but then we're going to plug it back in so we can configure our wireless network. Okay, I'm going to plug the SD card back into my card reader, and it will open up two windows, one over the other. There's this root FS and the boot. We want to put our files in boot. Let's open a terminal. If I do a df-h, I can see that those are mounted. So this is the one we want to go to. Now, on my system, it's /media/MB Rowan is where they get mounted. It'll be different under, well, it'll be different because you've got a different computer, but you'll navigate to that file system regardless of which OS, you'll figure it out. So the first thing we need to do is we're going to do a touch SSH. If you don't have the touch command on your platform, you just need to create a file. It can have data in it or no data at all. Touch will just make a zero-size file named SSH. When the Raspberry Pi boots, if it sees that file exists, it will start an SSH server when it boots up for the first time, which is what we want so we can log into it. And the other thing we need to do is create a file that contains our networking information. So we're going to edit. Before I do that, I should mention that this file is pretty sensitive. Your editor should not put carriage returns into the file. If you can do this from Linux, that's probably the best. Mac should have no problem. Windows, you might have to do something special with your editor so that it doesn't put carriage returns in. All right, so we'll do I'm going to use VI WPA under supplicant.conf. Now this configuration file is usually located in /etc/WPA_supplicant. But when it sees it in this boot directory, when the Raspberry Pi boots up, it will see that and it will move it to that location and it will know to start up and bring up a network. So this will be a blank file. If we do a quick web search for, let's see, we'll do Raspberry Pi WPA under supplicant.conf /headless. It'll bring up this raspberrypi.org article on it. So it talks about how to do what we're doing. It may be vague in some places, but all right. And here they give us an example of the WPA supplicant conf file. So I'm going to copy everything in here. All right, so I'm going to paste what I copied into the file. And you would need to make some changes. First of all, you put your two-letter country code. For me, that will be US. And then here's where your network information goes. You would put your SSID and then your password in this PSK field in double quotes, and then you would save that file. Once you have those two things, you've created the SSH file, either an empty SSH file or something with some text in it, that's fine, just as long as it's named SSH, lowercase SSH. And then you create your network information in the WPA_supplicant.conf file. Then we should be ready. So we would eject the card. Make sure you do that. You don't want to just pull it out. Okay, it's now safe to remove the drive. So let's remove that, and we will put it in our Raspberry Pi and see how it goes. We're going to take the SD card and plug it into the Raspberry Pi Zero, like so. And then we've got a nice case. I'll snap it into the case. We're going to connect the power supply. And then we'll power it on. All right, I'm back at my Linux computer with a terminal window. Let me reiterate that you need to wait at least 5 minutes, if not a little longer, for your Raspberry Pi to boot up for the first time. It's doing extra steps like expanding the root file system, etc. So if you get too impatient, you won't be able to reach it and you may be frustrated. So give it ample time to boot up for the first time after you've put the card in. All right, the first way we can try to find the IP address of the Raspberry Pi is try to do an ARP-A. If you did an ARP-A and nothing came back, you can do AR-ping. This is from my Linux computer. Obviously, we haven't accessed the Raspberry Pi yet. So you would type AR-ping-A and then your network name. In my case, it's 192.168.1.0. That last part depends on what your subnetting is set up to. I have a slash 24 CIDR. So let's try this. And it'll keep pinging until you hit break. So give it a few seconds to issue this a few times. This is basically a broadcast ARP saying, you know, that will go to everybody or anybody on the network. So if the Raspberry Pi is out there, it should respond. So now if we do an ARP-A, it is listed here. And I have tested this when it's not available in the ARP cache already. So that is a good way to do that. And one more note on networking. If you're getting frustrated or you're unable to reach the Raspberry Pi or figure out its IP address, you can always connect an HDMI monitor and a USB keyboard to the Raspberry Pi Zero, and you would get a login prompt there. So you would be able to log in and see what's happening. It could be that there's an error in the WPA supplicant.conf file. If it has tabs, if it has carriage return characters in it, that's going to cause problems for it. It won't read things correctly, and it won't have the right password, or it won't be interpreted correctly. You could have a typo in that file that would prevent it from booting. So, and of course, there are other network issues. Maybe your Wi-Fi network requires more than just the SSID and password. In those situations, hook up a monitor and a keyboard, and you should be able to figure out and troubleshoot the network setup or manually configure it. And there's plenty of help on the web to get you through that. All right, let's see if we can reach it now. So we'll do an SSH to Pi, because Pi is the username we have on the Raspberry Pi, at 192.168.1.63 in my case. All right, it's asking about the host key, the fingerprint. We'll say yes. All right, so the password by default is Raspberry. And we're into the Raspberry Pi. The first thing we'll want to do is change the password. So current password is Raspberry Pi, or is Raspberry, sorry. New password is going to be whatever you want. One more task we need to do on a Raspberry Pi, and that is to do an update and an upgrade. So we're going to type sudo apt-get update, and we'll let that run. That can take a couple of minutes to run, so I will pause and come back when that is done. All right, that just took a few minutes, and it's done. And now we're going to do sudo apt-get upgrade. And this is going to grab any new packages that have been updated since this version was released. And it's important to do this because you want the latest packages, so if there are any bugs, those will have been fixed, hopefully, and won't introduce new ones. And also for security reasons. There's a lot of security packages, a lot of updates for security reasons. So we'll go ahead and run that. This can take a good long time depending on your network bandwidth, time of day that you do it. All right, it's going to ask us this operation is going to require this much more space. Do you want to continue? We'll say yes, and we'll let that run. That can take anywhere from 5 to 20 minutes, so we'll pause again until that's completed. Okay, that's completed. Looks like it took about 15 minutes. So now we want to reboot the Raspberry Pi Zero, so we will do a sudo reboot. We'll lose connection to the Raspberry Pi Zero, but when it comes back up, it should be reachable again. All right, it shouldn't take 5 minutes this time to reboot the server. Let's see if we can reach it. Okay, I'm getting prompted for password. Okay, so we're in. We've got access to the Raspberry Pi Zero. It's up to date, and we're ready for our next steps, which will be in Part 3. This completes Part 2. In Part 3, we will install and configure CUPS, the Common Unix Printing System. Thanks for watching, and we'll see you in Part 3.